Hello, in this video I'm going to provide you with an overview of graphing that's necessary for your student-designed experiment and the graph you're going to need to produce there. First of all, the content and language objectives. The content target is I can identify common graphing mistakes, and then the language target, I can write feedback for another student about how to improve their graph. Second thing here, graphing topics. So I'm going to cover three things here. First, what type of graph should be used and when. Two, what variables go on what graph axes? And then three, what are some important things to include in a graph? So first of all, there are lots of different types of graphs, as this picture shows, that can be used for lots of different things, whether you're showing the relationships between two different variables, composition, distribution, comparing things. And so you can see dozens here. We're going to talk about three particular types of graphs. First is not so much a graph as a chart, maybe. It is a pie chart. And a pie chart, the main function is to look at parts of a whole. So if we're looking at the United States federal budget in 2019, there are two different pie charts here that show of the whole, outlays or amount of money that is spent, and then revenues, money that's brought in. Where do those parts go? The second type of graph we're going to talk about is a line graph or a scatter plot graph. The key thing for a line graph or scatter plot graph is you're looking at two different variables. For a scatter plot graph or for a line graph, you should have numbers on both the x and the y axis. And then third, this isn't so much a column graph or a bar graph because it's showing wind turbines here as opposed to bars. But what you would do is look at different things on an x-axis, not numbers, but anything other than a number, compared to some values on the y-axis. So instead of comparing numbers and numbers, you're usually comparing things and numbers. When you're graphing, there are a lot of common mistakes that people make. And so what I wanted to do is just go through some of those. The five different things here that are going to be mentioned, we'll go over, but this is a decent looking graph. One thing it should have is it should have a title. You should always have a title for a graph, and it should have two different things to it, whatever's on your x-axis and whatever's on your y-axis. Second of all, you should always have your independent variable, what you're changing on your x-axis, the horizontal axis, and whatever you're measuring should be on your y-axis. Next thing is your variables. Your intervals should always be the same. And so it doesn't matter what they change by, and you don't need to start at 0. But if one dash here represents 3, it should always represent 3, as opposed to what you can see here, where it's kind of an interval mess. It's not easy to look at. It's complicated because of this. And then you also need labels. As you can see, time's measured in seconds and velocities measured in meters per second on this graph. So those are some things that you should always make sure to take care of. As you can see in this graph below, it's very difficult to read what's going on. You can't initially look at it and see what is being compared, what's the relationship being studied. There are no units. You don't know if you're talking meters or kilometers, minutes or seconds. And so if you're missing any of those components, then you're going to have a more confusing, more difficult to interpret set of data. The last thing here is whenever you're producing a scatter plot graph, you don't need to have your line. If you're producing a line of best fit that goes through the origin here at 0, 0. So those are just some things to keep in mind as you graph. Finally, what is your assignment here? Your whole purpose for this video is to provide you with details on how you can produce a graph for your student designed experiment. And so what your assignment here is to produce a graph using fake data. You'll eventually collect data and you'll produce a graph, but it's easier if you can just take a look at like what should your graph look like? What are you going to have on your x-axis, your y-axis? What are you changing? What's your independent variable? What are you measuring? What's your dependent variable? And then what you're going to do is after you have produced and submitted a fake set of data for your student design experiment, what you're going to do is peer review three other students and provide them feedback on their graphs. And you're going to look for the things that I just talked about in this video. Do they have the right type of graph? Do they have the right things on the right axes? Are their intervals the same? Do they have a title? Do they have labels? That's it. If you have any particular questions, please feel free to stop by during the office hours. And also, you're welcome to email me, and I'll try to get back to you as soon as I can. Thank you.